So what we're going to do is now we're going to take these triangles that I created up here, and we are going to place them inside the unit circle. So this is the first triangle that we're going to look at. Okay, it's the 30, 60, 90. So what I want you to look at is we've got this 30-degree angle right here. We've got a triangle kind of right there. Okay, so this is my 30, 60, 90 triangle. So if I look back from what we did yesterday or the last video, okay, this longer side right here, and let me kind of just point to which we're looking at, okay? This right here is going to be the x value of the coordinate. So I go over this square root of 3 over 2, and I go up 1/2. Okay, because that is the kind of this leg and then this leg put together. Okay, that's how many I go up and over. So disregard the fact that those are the variables from yesterday or the other video, x and y. That doesn't matter in context of the fact that we placed this triangle like so. Okay, our next triangle that we're going to do is the 45, 45, 90. So let me change the little highlighter color here. Okay, we've got the 45-degree angle. I'm going to kind of put a 45 here. Let me straighten it out just a little bit. Okay, there's my right angle. And then right here. Now we do know that a 45, 45, 90 triangle from the last video has the same leg values. Okay, so it's the square root of 2 over this over 2 for the x value, and then the same for the y value because it's an isosceles triangle. Okay. And then our last one is going to be, which color shall we do? We'll do the blue. Okay. So then we have the 60 and then the 30 kind of down right here. Straighten that out. Very good. There's my 30-degree angle up top and then the 60-degree angle. So does everybody see that we placed these special right triangles within our unit circle? And in this case, from the other video, my 60-degree that's like right here, this right here is 1/2. So I go over only 1/2. So that would be my x value. And then I go up the square root of 3 over 2. Okay. So that's kind of your first quadrant. Now, I know that that sounds really overwhelming, but let me be very clear. This is really the only set of numbers that you need to be more familiarized with because these numbers are going to repeat in each quadrant. And as long as you understand the quadrant rules of the coordinates, then you should be golden, right? Gonna be golden. Okay, you should be golden if you understand the quadrant rules. So now we're going to take this first quadrant and we are going to fill in the unit circle. Now, the unit circle is this. It's the same today, yesterday, tomorrow, in 55 years, 2,000 years ago, like whenever it was invented, it is the same. Okay, it will never change. So if you wanted to memorize it, you absolutely could. There would be no harm in memorizing it. But could you get away with just knowing the first quadrant? Yes. But those of you that are going to go on to AP Pre-Calc and Pre-Calc and maybe Calc, you're going to use it. Like I was literally just helping somebody at lunch today with the unit circle. So it's going to be used a lot. So you need to just make sure that you know it, especially if you are going to that next level of pre-calc. Okay. So again, today, yesterday, forever, always, all the time, tomorrow, it'll be all the same. So let me kind of give you the pieces of the puzzle. Okay. All the way around the circle, you're going to find the degrees. So if you look, you've got a 30, a 45, a 60, 90. And then these bigger, kind of what I call pizza slices, are going to be worth 30 degrees. Okay, which is how we get from 90 to 120. These little pizza slices are only going to be worth 15 each. Okay. And then that pattern consistently goes around the circle. The big pizza slices are worth 30 degrees and the little slices are worth 15. Okay. So you could come up with all of the degrees all the way around the circle. We've got 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and a positive 360. That gets me one revolution. Okay. Now, the other thing that's within the unit circle are the radian measures. Okay. Meaning taking our degree, oops, not writing on the paper. Cool. Degrees and converting them to radians. Those are going to go right here in these little blanks. Okay. So if you're going to add or embellish any other value, your radian value of that specific degree would go right here. So I give you a second. Now, this is 0, but it's also 360. So a lot of times you will maybe potentially see two blanks there. Now, 0 pi is still 0. So that radian is 0. Kind of silly, but whatever. Okay. And then 360, we did kind of the other day, is 2 pi. So let me, here's my handy dandy. Let's take a second and we're going to fill in the radians just so that we can get it done with and it can be done and then we can look at the coordinates. Okay. So if I do 30 times pi over 180, I'm not going to write it with the pi. I'm not going to type pi into my calculator. So I'm going to do 30 divided by 180, math, enter, enter, and I'm going to get pi over 6. Because again, from the rationals unit, I multiply fractions, top with bottom, okay? So this would be 30, oops, and I'm writing off of paper, 30 pi over 180, and we would reduce the 30 over 180, okay? Cool, 45 divided by 180, math, enter, enter, pi over 4, oops, wrong box. And then what I would do is I would keep going, right? Just keep going. Pi over 3, pi over 2, 2 pi over 3, 3 pi over 4. So if you're like, oh my gosh, how's she doing that so quickly? What I am doing in my calculator is I am doing, we'll take the next one. I'm doing 150 divided by 180, enter, and then math, enter, enter. Okay, that's all I'm doing. So 150 divided by 180, enter, math, enter, enter, 5 pi over 6. Okay. Mhm. Sorry about that. All right, so here we go. Beep, 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 beep. You work, I work. You work, I work. Here we go. Here we go. You work, I work. We're turning it into radians. Ooh, boo, boo, boo. 240, ba-da-da-da-da, 240, ba-da-da-da-da, 4 pi over 3. Ooh. because you'll see new and a bit alarming, but she won't discover that it's him till chapter 3. Anyway, all right, there you go. We converted them all into radians in song form, of course. Anyway, sometimes I don't understand why. Okay, here we go. So now I'm going to look at the coordinates on the outside. So those are the pieces on the inside. Now we're going to go to the outside of the circle. Here we go. So we already filled this in. It's 1, 0. This one's going to be 0, 1. Let's fill in the 180. Let's fill in the north, south, east, west. Okay. If I go to this coordinate, this means that this is a negative 1, and I go up or down, none. Okay. And then if I go the 270, I go left or right, none, but down 1. So that's why that's a negative 1. So there are my pieces of the puzzle. Okay. Now I'm just going to copy what I did in this first quadrant right here. So this is going to be the square root of 3 over 2, and then 1/2, and the square root of 2 over 2, the square root of 2 over 2, the square root, oops, I'm lying to you, 1/2, square root of 3 over 2. Okay, now, if I were live teaching with you, it'd be awesome, first of all, because it would be cool. And then second of all, I would get my ruler out and I would be like, oh my gosh, don't you see how this point connects with this point and how this point connects with this point? But I can't. Okay, so I'm gonna need you to think about it. Okay, is if I want to fill in the 120-degree angle, because that's my next kind of rotation, that's where my next angle is that doesn't have a coordinate. Which point from the first quadrant matches with the 120? Do you see it? Hopefully you do. Okay, it's in line with the 60-degree angle. So it's going to have the same exact coordinate because it's equivalent, like it's the same spacing, same height, same spacing from the origin, except it has to follow the quadrant rules, the coordinate rules. And we said back over here that the x coordinate was negative, the y coordinate was positive. So instead, this is going to be negative 1/2 and a positive square root of 3 over 2. Okay. Okay. 135 lines up with the 45-degree angle. So again, as long as it's in the second quadrant, it has to have a negative x and a positive y. 150 lines up with 30. So it would have the negative square root 3 over 2 and then 1/2. I know that doesn't look like a negative, but it's there. Okay. Cool. So let's go down to the third quadrant. What do we know about the coordinates here? Both of them are going to be negative. So we have to figure out which one lines up with which. Which one lines up with 210? Hopefully you said 150 and you're starting to connect this like perfect kind of a roundabout situation. Okay, this one matches with this one. So it's going to have the negative square root 3 over 2 and a negative 1/2. The 225 matches with this one. So it's going to have the negative square root 2 over 2, negative square root 2 over 2. And we could fill in, I feel like we could fill in this. What do you think? Do you think we could do it? Do you think? There's so many people yelling at the hall. I don't know what's happening. I'm just going to stay in my little bubble. So You guys did it. Look at you go. I'm so proud of you. I'm so proud of you. So proud of you. Okay, so how do we even use it? Right? So how do we even use it? How do we even use this stinking unit circle? Okay, so I surely hope that you are able to look at this unit circle and kind of have it there. I will try to have like pre-filled in unit circles for you guys so that it's easy peasy lemon squeezy. But if you could, I'm not really sure what this packet looks like. I kind of forgot. I don't know how many pages are in here. 16. So, okay, so you might have to it might be like a flippity flop, or you could like fan your packets out and like try to look at them at the same time. Or you could kind of rip your packet staple off and you kind of have the unit circle here and have this next page here. Okay. So here's the types of questions that you would be asked. Okay. Given the unit circle, it'll say write the or find the exact value for each trig function. Okay. So remember sine and cosine and tangent. We wrote down that the cosine was the x value and the sine was the y value of that coordinate on the unit circle. And then the tangent of theta is equal to y over x, which is the sine of theta over the cosine of theta. Okay, based off of just the coordinate right there. Okay, so the question, the first thing is what value, like which one. Okay, this asks a what or slash which one. This tells you where. So what and where. Okay, the sign tells me that I'm looking for the y coordinate. Where at the 150 degrees. Okay, so here I go. I'm going to find 150 degrees and I want the y value from there. So I found it. I already looked at it. I saw it. Here's the 150. Here's the y value. So my answer would simply be 1/2. What or which one, whichever one, which coordinate, where is it at? What value are you looking for and where? Okay, so let's do some more cosines and tangents and then or cosine and sines and we'll look for tangent here in a second. Okay, cosine. So what? I'm looking for the x value. Where? At 225. So x value at 225 is what I'm looking at. So at 225, here I am, right here, and I want the x value. So the negative square root 2 over 2. Oops. Now, because we already wrote this in radians, this is saying the where is just the radian measure. Now, I'm going to give you these, so it's totally fine. Okay, so what? This is the x value at the 11 pi over 6. So I'm going to go back to my circle. I'm going to find 11 pi over 6, which is right here, which is the 330-degree angle, and I want the x value. So this is positive square root 3 over 2. So positive square root 3 over 2. All right, the sine, again, we're jumping around. We're doing the sine and cosines first, and then we'll go do tangent, and then we'll do the reciprocals. Okay, the sine of 4 pi over 3, the sine is the y value at, oh, if I could spell, at 4 pi over 3. So 4 pi over 3 is here, and I want the y value. So the negative square root 3 over 2. That make sense? Feel good? All right, find sine of 7 pi over 6. Do number 15 right here. I want the y value at 7 pi over 6. 7 pi over 6 is 210. And I want the y value, so that's negative 1/2. Negative 1/2. Okay, cool. Tangent. Tangent. All right, tangent, remember, is the y over the x. So I'm going to have to take the y value and divide it by the x value. So yeah, I did a bad fraction. So I hope that you remember that rationals unit. Here we go. 300. This is my coordinate right here. Okay, so I'm going to write that down. 1/2. And then a negative square root 3 over 2. So I want the y value, which is negative square root 3 over 2, over the x value, which is 1/2. So keep, change, flip. So negative square root 3 over 2, change to multiplication, and then flip the second fraction. So these 2's go away. One's on top, one's on bottom. I would have negative square root 3 left over on top over 1, which would be left with negative square root 3. Okay. 240. So if I go up to 240, I have negative 1/2 and negative square root 3 over 2. That's literally the almost exact same thing, but we're going to do it anyway. So again, I'm looking for the y over the x. I'm going to do the negative square root 3 over 2 over negative 1/2. I'm going to keep, change, and flip. So this is now negative 2 over 1. Doesn't matter where the negative goes. Doesn't matter. Pick one. Doesn't matter. That goes away. Those 2's, one's on top, one's on bottom. And a negative times a negative turns into a positive. So now this one is a positive square root of 3. So that's positive square root 3. This one is negative square root 3. Okay. Tangent of 3 pi over 4. So if I go 3 pi over, 3 pi over 4, this one right here, 135. So this one is those first square roots of 2, but this is actually not bad. So remember, it's negative square root 2 over 2, square root of 2 over 2. So it's the y over the x, so it'd be the square root of 2 over 2 over negative square root 2 over 2. Now, if you see it, great. If you don't, you're going to have to do the work. Here we go. Keep, change, flip. Twos go away, and square root of 2's go away. So this would be negative 1. Anything over itself. Anything over itself is 1. All right, last thing. Okay. Are there reciprocals? Okay. So let's start with, I don't want to do cotangent first. That sucks. We'll do secant. Okay. Now, secant, if you remember, if you recall, let's scoot it back. Okay. Secant goes with cosine. Cosecant goes with sine, and cotangent goes with tangent. So if I'm at secant, this is going to go with cosine, right? This is 1 over cosine. It's the reciprocal of cosine. If you want to think of it as like SC, like one of the S's has to have a C. You can't have like 2 S's. So secant can't go with sine because those are double S's. Cosecant or cosine can't go with cosecant because those are 2 C's in a row. You got to have alternating letters if that's how you want to remember it with secant and cosecant. Cotangent has it in the name, okay? Don't even with that, okay? But secant goes with cosine. Cosecant goes with sine. Math's weird. Okay, we got that. We already understand that. It's like we're expecting it to be weird. Okay, here we go. So the cosine is the x value. So when I find the x value, I am going to reciprocal it, meaning I'm going to flip it. That's what I mean. Okay, and I actually don't like that. So I'm just going to flip the x value. So let's just find the x value first, and then of 300, and then we'll go from there. Okay, so the x value at 300 is this right here, which is 1/2. Ooh, not bad. Okay, not bad at all. So if the x value is 1/2, I want the secant value, which means I'm going to reciprocal this. And so my finished answer would just simply be 2. How exciting. Okay. Cosecant of 7 pi over 4. So this is the reciprocal of sine. Sine is the y value. Okay. So when I get the y value, I'm going to flip it. So 7 pi over 4 is the radian. So here we go. We're going to find it. 7 pi over 4. Ooh, yes. Cool. I'm looking for the y value. That's this one. So negative square root 2 over 2. Negative square root 2 over 2. Now I'm going to flip it. So here's where the stuff gets weird. Okay. You could absolutely not leave your answer like that. Okay. You cannot have a radical on the bottom. Okay. You learned that in math too. So in order to get rid of the radical on the bottom, we have to multiply by the denominator. Okay. You got to multiply by the radical. So we multiply by the square root of 2 over the square root of 2, because if we do it to the top, we have to do it to the bottom. Okay. If we do it to the bottom, we have to do it to the top, vice versa. So now we multiply fractions. You just thought you were done with the rationals unit. Okay, cool. So negative 2 square root 2 over 2, right? Because this right here is the square root of 4, and that goes down to 2. Then I can simplify the fraction, which is 1. Those go away, and I'm left with negative square root 2. Now, remember what I said. The unit circle is the same yesterday, today, and tomorrow. 50 years from now, next year when you go to pre-calc, next year when you go to math 4, in a year when you decide that you're gonna need something for college, like whatever, it's the same. So the cosecant of 7 pi over 4 today being negative square root 2 is gonna be the exact same tomorrow. So we've done this hard work, but it's really the same answer over and over again. Do you have to memorize it? No, but should you know how to find it? Absolutely. Okay, at some point, right? At some point. All right, cool. We got 2 more. And then I will set you free. I will set you free. Secant, pi over 2. Here we go. Pi over 2 is at the 90. Okay. Secant goes with cosine. Cosine is the x value. I don't know why I highlighted that. Okay. So this is x value. This is I want to write it. This is the x value. So we're going to flip it. The x value is 0. 0 over 1. When you flip 0 over 1, you end up getting 1 over 0, which is now undefined. And there you go. There's your weird one. Okay. There's always 1 or 2 or 3. Okay. Cool. Last one, cotangent. Now, cotangent belongs with 1 over tangent. Now we know that tangent is the x or the y over the x. So what I could just do is know that, could bypass all of that. I know that the cotangent is just x over y. So if I go ahead and write it as x over y, I'm golden. I do not have to flip it. But if I want to write it y over x and then flip it, by all means. I always do x over y, so then I don't have to really think anything else about it. So here we go. 315. That is, oh, this one's silly. We've already kind of done this because we did 7 pi over 4. Oh well, it's fine. It'll be good practice. X over y. So the coordinate is the square root of 2 over 2, negative square root 2 over 2. So it's going to be the x, which is the square root of 2 over 2, over negative square root 2 over 2. Well, if you see it, anything over itself is going to be 1, and then there's a negative on the bottom. So that'd be negative 1. Okay, I feel like I should do a little bit trickier of one with you, but what's 150? Yes, we need to do the cotangent of 150. So jump down to number 10, and then I'll stop talking. Okay, the coordinate for 150 is the square root of 3 over 2, negative square root 3 over 2, positive 1/2. Cotangent is x over y. So I'm going to do negative square root 3 over 2 over 1/2. So it's keep, change, flip. Okay, these go away, and you're left with negative square root 3. Okay, cool. So what I would probably say is that you probably should hit up the rest of page 14, and then there is a maze for you to do. Whether myself or Miss Moore want you to do it today or maybe tomorrow, I don't know. I would just get super familiar with all of this because this is definitely on the EOC and it's definitely on your test. Okay. I'll see you guys for the last section, page 16, in the next video. Bye.